All right, I think we can get started. My name is Christina Donnelly. I am on the board of the Embankment Preservation Coalition, and we're really thrilled to be one of the co-sponsors of this session with Dr. Baker. The slide has all of the co-sponsors. It's sort of too many to list, but we thank them all for co-sponsoring with us tonight. And I would like to just do the Zoom reminders to mute your line, and also that we are recording this and it will be up on our embankment.org website, in the next couple of days once we put it on the website. I'm going to introduce Peter Delman, also a board member, and he will introduce Dr. Baker.
Thank you, Christina. I'm Peter Delman, a founding member of the Embankment Coalition and current treasurer. Welcome to our talk on the challenges of climate change in 2021. Dr. D. James Baker will be presenting today, so thank you, Dr. Baker. Dr. Baker is a physicist and oceanographer who has served in many academic, nonprofit, and governmental positions. In the Clinton administration, he was the head of the National Oceanic and Atmospheric Administration, or NOAA, and later served as the director of the Global Carbon Measurement Program at the Clinton Foundation, specializing in reforesting programs in developing countries. Currently, he is advisor to a software company based in Australia, working on forest management. This evening, Dr. Baker will give us an overview of what has been called the existential crisis of our time. There will be a Q&A period at the end of the program. Dr. Baker's second talk on Thursday, May 13th, will focus on solutions. We're hoping that coalition supporters will be inspired by these talks to get involved in current city master plan efforts that will determine the direction for open space and land use in coming years. This is one important way for each of us to do our part in tackling the global climate threat. Jim is also my brother-in-law. He is a successful leader because he is a lifetime learner, an attentive listener, and a caring person. He's worn many hats, including as U.S. Commissioner to the International Whaling Commission. I remember when he was wrestling with the fraught issue of whale hunting. He asked our young daughter, a passionate animal lover, what she thought. Jim's kindness and understanding expressed during their conversation remain vivid in my memory all these years later. And Jim is looking forward to interacting with you too at the end of the program. So be sure to ask your questions using the chat function on your screen.
Thanks, Peter. And thanks to Maureen and Christina and Peter for organizing this session. And thanks to all of you for joining tonight. You've been hearing a lot about climate change lately, and rightly so. It's one of those overarching topics that touches all aspects of our lives. It's important that we all understand what the causes are and what the solutions can be. And so I've given these two talks titles of the challenges, that'll be the first one, and solutions for the second one. I've had the opportunity to be involved with climate and oceans issues for almost 60 years now, and I've seen interest and engagement grow dramatically over that time. I hope I can share some of that interest and engagement with you tonight and in the second talk. So let's get started. That thin blue line in the middle of the slide is a picture of Earth's atmosphere taken by a NASA satellite, and then peeking through it in the middle is the sun. That's the thin layer that is our life support, and that's where we'll focus our attention tonight. We'll start with a brief review of the science, and then we'll look at the impacts, and then what nations have come together to try to do. That'll be the first talk. The second talk then we'll focus on the solutions and all those interesting things that people have been doing. So let's let's look back in history to get started. If you look at this graph, this is a graph of the temperature variations in the atmosphere for the past 10,000 years. We call it the Holocene temperature variations. That's the geological period over here. And the interesting thing is you can see that the temperature hasn't varied more than about plus or minus 1 degree Fahrenheit over that 10,000 years, over the period from the beginning of agriculture to the building of the Great Pyramids, to the Roman Empire, and almost up to the present. For our own purposes, it's also important to recognize that coal was discovered about midway there, somewhere between 5,000 and 6,000 years ago, and really possibly earlier. So over this whole period, we've been getting energy by burning things, either wood or coal, and then later oil and gas. But in the past century, global temperatures have increased dramatically. You can see that red arrow, and I just circled it there. And it's dramatically above the temperature that we've seen for the past 10,000 years. Now, this is really the main point that we want to remember, that we're seeing something that's very different than we've ever seen in the past. And it's causing the Earth to get warmer. The cause of this increased temperature is the increase in carbon dioxide that's coming from burning fossil fuels. It's also well above the 1,000-year average. You can see on the right with the red arrow, that's the current level of carbon dioxide, and that graph extends back actually 800,000 years. So you can see we're in a very different world today. Well, what's the cause of all this? The cause is the increase in carbon dioxide that has happened since the beginning of the Industrial Revolution, and that's right around the late 1700s. You can see the red circle shows that. The measurements earlier than that come from Antarctic ice cores, but modern measurements are direct measurements of CO2 with modern measuring devices. So once again, you can see that we're well out of the norm that society has developed over thousands of years in the past. And if you look at recent temperatures, it looks something like this. This magnitude of temperature increase and the rate of temperature increase, here's an arrow to show you that, since roughly the 1950s, it's unprecedented. We've never seen this in the record before. So where does this come from, and what can we do about it? These are the questions of global climate change. So we have to go back and look at the science of this. How is the Earth's atmosphere made up, and what are the impacts of those constituents? You all know the atmosphere is made up of 78% nitrogen, 21% oxygen, with a few trace gases, a little bit of argon. But the trace gases are the most important: water vapor, carbon dioxide, methane, nitrous oxide, because, as you can see on the right there, they're complicated molecules, more than just two atoms stuck together. They have the opportunity to rotate and vibrate and absorb energy and radiate energy. These are the greenhouse gases. They make the atmosphere warm. A greenhouse gets warm, and that's why we use this term greenhouse gases. But it's important, I think, to look at how it actually happens. Here are some of those molecules. In the middle is water vapor with the yellow and the blue. Up on the left there is carbon dioxide getting a pulse of energy and then radiating it out back again. And then down in the bottom, you can see the methane molecule. It's got a hydrogen and it's got a carbon and 4 hydrogen. So it's even more complicated. Well, the idea that these molecules could absorb energy and make the atmosphere warm goes back as far as the 1850s. And actually the first experiments that were done on this was by a woman scientist, Eunice Foote, working in the US. And she discovered that carbon dioxide would actually absorb sunlight and cause the atmosphere to warm. And since then, I just put up one of the many textbooks. This is by Richard Goody, professor at Harvard, on that topic. This is something that is well understood, the greenhouse gases, but I think it's important to get sort of a feel for it with these gases. I call them dancing around. And remember, every time you burn some fossil fuel, you're adding more dancers to the dance floor. You can see them bouncing around there in different ways. Well, there's a natural greenhouse effect on Earth because before we started adding the greenhouse gases, there were the trace elements were there, the carbon dioxide, methane, and others, and they actually caused the Earth to be about 60 degrees warmer than it would be otherwise. They take the Earth from being a frozen planet to one that can support life. So the natural greenhouse supports life. But what we're talking about today is the human enhanced greenhouse effect. That is, if you add more of these greenhouse gases, the Earth gets warmer, less heat escapes into space. So in fact, the upper atmosphere gets cooler, but the lower atmosphere where we live gets warmer. And it's this warming effect caused by these greenhouse gases that really is the basis of climate change. It's what drives climate change. Well, we know the physics pretty well, as you can see from that early work and of Eunice Foote, and then many people later. We can predict scientifically what we expect the temperature rise to be with a certain amount of carbon dioxide, and in fact, the calculations show that we're right on, and the same is true for the stratospheric cooling. So we have a very good sense that the science is accurate and that we know what we're talking about. And actually, there's an extreme case of the greenhouse effect that's on Venus. Venus is 97% carbon dioxide, and it has a temperature of almost 880 degrees Fahrenheit. That's boiling hot. So what has happened on Earth? Well, here's a picture that NASA put together. It's a little film image that starts in 1880 and it goes up through 2020. And I just have it stopped here for a minute, just to give you a sense. You can see the continents, and it will slowly move through time up to 2020. And what's important to watch, now I've started it here, it's not that the world warms uniformly. No, it doesn't do that. What it does is some areas get warmer than others, then they cool down, then some other areas get warm, but overall the average is warming. We're up to about 1970, and as you look now in the 1980s, it's getting warmer and warmer, particularly near the Arctic region. And as we get up now to 2020, you can see that the northern polar regions, for various reasons that we understand pretty well, get warmer than the rest of the world. But there are important parts of the world that are getting warm and have a particularly dangerous impact. Looking in developing countries, if you look down here in the Amazon, for example, you depend very much on water supply to maintain the Amazonia forest. And if that's drying up, that's obviously an issue. West Africa is an issue with a lot of subsistence farming. The Arabian Peninsula is already dry, and it's going to get drier. And then millions of people in China are being affected by the warming. So just to give you a few ideas, and if you can see down on the lower right, we also have Australia is getting warm, and you've seen some of the wildfires down there. Well, what about locally? Here's the average temperature in Newark from 30-year averages from 1951 to 1980, and then going up to 1988 to 2017. Typically, the climate numbers are taken from 30-year averages. And you can see there's been a temperature increase from something like 1.5 degrees, 54.3 or something like that, up to over 55.5 degrees. So there's a steady rise in temperature. Now, you might say, and you would be justified, I think, that a change of 1 degree of our average temperature is not going to affect us that much. And that's generally true for developed countries. Small changes don't make a difference, but where there is a big difference is in the extremes. Typically, this is how our weather is distributed. Any given day will have an average temperature. There's some probability that it will be very cold or some that it will be very hot. This average will change with the seasons. But this is how we see it. But if we change that average just a little bit, and here's how that would move, you can see that there's more probability of getting extreme heat, less probability of getting extreme cold. So what you have, if the average temperature of the world is going up just a little bit, you have a much bigger change in the extreme heat. Extreme heat means heat waves, And heat waves are one of the biggest killers in terms of weather phenomena. So this is something that is serious. And of course, it affects agriculture too. That's another important aspect of the extreme. So we have to think about not only the averages, but also the extremes. So what has happened locally? Well, if you look at Newark, you can see that records are being set, new hot records, more hot records than cold records. And this is exactly what you would expect. As that curve moves over to the right, you get more hot extremes, fewer cold extremes. And this is up to 2010, but that has continued to happen. And it's these extremes that really cause issues with the way in which we live our lives. If you look at whether we're actually seeing this in the rest of the world, I mean, the rest of the United States, here are extreme humid heat days over the US since 1980, about a 40-year record there. And you can see every state has an increase in the humid heat days. Some are less than others, and it would be interesting to think about, why is one state dramatically different than another? But the fact is, it's all going up. And this same extra heat also evaporates more water from the ocean. So more water from the ocean, more water in the atmosphere means increasing rain and floods. But what happens, as you might expect with the atmosphere, it's not a simple distribution, and distributions change as the winds change. And so the patterns of precipitation also change. So we end up with more rainfall in some places and less rainfall in others. In other words, longer and stronger storms and deeper droughts. And these are things that are important for society, but very, very important for developing countries and for farming. Are we seeing this? Well, yes. More downpours. Here's an increase in heaviest precipitation events. You can see 55%, 29, 10, 42. Even in the dry states, you're getting an increase in the heaviest rainfall events. And of course, it's the heaviest rainfall events that are the ones that cause the most damage. So this is obviously an issue. We're also seeing more drought. Just as I said, this is the drought index, which is measured by the amount of water in the atmosphere, but also the amount of water in the soil moisture index. And if you plot this versus time, you can see that we're getting more of these severe droughts. So we're seeing more strong rainfall, more severe droughts, exactly what we would expect. And of course, with the drought, you've got the dry areas, so you get more fires. Here's a picture taken by some Defense Department satellites of the fires in California in June 2019. You can see them up near the Bay Area, and down on the right, the kind of fire that we expect to see. This is really a first in terms of observations. These for many years you couldn't see these fires except on the ground, but now they have satellites that can actually see the small fires as they start to develop and help get support out to try to stop the fires. So this warming also causes glaciers to melt. It causes the Antarctic ice shelf to melt. That's what that picture is up on the left. The glaciers in the Himalayas are melting, and we're seeing strong floods and rivers coming down. There's one from in the northern India in the Himalayas, almost inundating a dam. But we're seeing it also in Miami. There's a picture on the right showing cars going through what now is a monthly high tide that inundates most of the big highways there in Florida. We see this melting in Greenland. Greenland is the biggest store of ice over land, and you can see the cumulative melt days. It's been growing every year, the number of melt days. And here's a picture, I think a nice picture for you to see how ice melts on a glacier and then forms rivulets, and then the rivulets run down, and then they run out to sea. It's a complicated process, and you can't just go immediately from saying, well, if this is going to be a certain temperature, I know how much water is going to melt. A lot depends on exactly how it happens. So we're monitoring this once again with satellites. And in the meantime, the Greenlanders are taking this water, bottling it, and selling it as the world's most pure water, Greenland ice cap water. You can buy this on the internet. Well, the Arctic ice is also melting. There's a difference between 1987 and 2013, and it's continued to do this. You can see the extent is much less in 2013, and you can also see that there's less white. That's the multi-year ice. So not only is there less ice at the surface, but there's less thicker ice. So we're looking, people are saying now at having an ice-free Arctic probably by the middle of the century, which makes a big difference to the way in which the world deals with its economy, because it gives you new ways and a whole new ocean to exploit in terms of resources. And the question is, how can you protect the Arctic Ocean so that you use it sustainably? One of the things that just happened this year, first time ever, was a Russian natural gas carrier actually was able to make its way with the help of a Russian icebreaker. You can see it here. The Russian icebreaker is moving through, and you can see behind it there. You can see the natural gas carrier. First time ever in January to have an a natural gas carrier come through what they call the Northern Sea Route. Both the Canadians and the Russians are really interested in what can be done with this, and they're interested in knowing whether, in fact, the Northern Sea Route might replace the Suez Canal as a favorite route. The Russians are doing everything they can to see if they can't get a cheaper route through the Arctic ice than through the Suez Canal. Whether that will happen or not, of course, depends a lot on the economics. But this is just one idea of the kinds of things that are happening. If you add up all of these different kinds of weather disasters, extreme weather events, and so on, you get a picture that looks like this. This is the numbers since 1980 to 2019. The yellow is storms, the blue is floods and mudslides, and the red is extreme temperature, droughts, and fires. This is just the number of events, and this is steadily increasing. Of course, we have more people in harm's way. We understand that, but the number of events around the world is definitely increasing, and the cost is going way up. Right now, the cost of those natural disasters in 2018, 2019 was close to $200 billion. So this has a real impact on insurance companies and on governments trying to make sure that they really can deal with these increasing numbers of weather catastrophes. And of course, if you've followed this subject, you know it's not just weather. Animals and ecosystems are affected by changing climate. As the climate warms, the animals want to move either northward to cooler climates or to higher elevations on mountains where it's cooler. And of course, they can move, animals can move, but many of their food sources and plants can't move. And so you have a mismatched timing between animals and food sources. This makes them more vulnerable to invasive species, and we see a number of plant species have gone extinct as they have not been able to migrate fast enough to more mountainous periods for areas, for example. We're seeing the cherry blossoms bloom earlier. Here's the difference between the early 1940s, 1950s, sorry, and early 2000s, where there was like a 5-day earlier appearance of the cherry blossoms, and that's even gone up by a few days now. Again, that we see earlier cherry blossoms this year. In fact, the cherry blossoms in Japan bloomed earlier than they had ever bloomed before in all of the, it's at least a 1200-year history that the Japanese have been catching, and then have been using. But we've also seen a change right here in Washington, D.C. You see the painted bunting in the middle of the picture here, beautiful, beautiful little bird. Normally winters over in North Carolina. This bird was seen for the first time ever in Washington, D.C. in the suburbs. So we're seeing birds migrating to new areas. And then over on the right, you can see the impact that warming has had on many coral reefs. We're seeing this particularly in the Great Barrier Reef in Australia. The corals are bleaching, the little animals that give the color are dying out. And of course, the more acid ocean that comes from the carbon dioxide dissolving in the ocean and making carbonic acid is also causing a problem for both coral reefs, but it's also causing fish to move. And you've probably heard about the way the lobsters are moving north in the North Atlantic. So here's another example. The pine bark beetle had not moved north for many years, but with warming climates, here's one in Colorado, the beetle has moved north and devastated thousands of acres of pine trees. The same thing is happening in Canada right now. This has been a huge problem with a warmer climate, happier habitat for the pine bark beetle. And so what you see is this devastated forest. The only way we can go back is get the temperature down as far as we know. So these warmer habitats, as you might expect, they're also good for tropical diseases. They have tended to stay in the tropics, but now as the earth is getting warmer, you've got West Nile virus, Chagas disease, dengue fever, Zika virus. These are mosquito-borne viruses, and even some cases of malaria. It's not generally true, but in some cases, malaria has moved out of its normal region. So this is an issue that is something that we have to be concerned about. We're all well aware now of pandemics and how diseases can move once they grow. Is there a connection between climate change and global warming and COVID-19? We don't really know. But what we do know is that providing a warm, humid habitat in new areas of the world provides a happy environment for the kinds of bats that carry COVID-19. And so there's an active research activity going on trying to understand whether in fact that we're seeing an impact here. So it also has an impact, global warming, on the food and farming. It's obvious that with the stress from increased weather extremes, it's harder to do farming, particularly as planting zones shift and the water moves from one place to another. So I mentioned the shifting rainfall zones. Also, with warmer climates, you get increased crop diseases and pests. So this all has an impact on farming, which is important for climate change because some of the important gases, I didn't talk about them too much at the beginning, but nitrous oxide and methane are important gases that are emitted both by plants and fertilizers and also by cattle. And cattle is important to us because today, this is the largest number of animals by percentage in the world today. We've moved from a world that had a very great diversity of large to medium-sized mammals to today, where it's mostly cattle. We have 10 times as many cattle as we have wild animals by mass, and about twice as many cattle as humans. But you can see the difference between today and 10,000 years ago, big shift. And in fact, if you think about the rumination of cattle and sheep and the fact that they burp up methane, it turns out that the world of cattle is like number 3 in greenhouse gas emissions because of the methane that they emit. So trying to find a way to help that rumination not eliminate so much methane into the atmosphere is an important topic for our second talk. in this series. Well, what's going to happen in the future? You know, 100 years ago, we were using the Farmer's Almanac to try to decide what the climate was going to be like. And there are people who use the Farmer's Almanac today. There's some truth to it because it's based on past experience, and past experience often gives us some hint into the future. But today we really rely on the basic physics of weather and climate and computer models to give us an estimate of what's going to happen. Now, of course, we don't know all the physics. There are certain things that we don't really understand yet about the physics of weather and rainfall and clouds and all of these different things. So we can't get an exact answer, but we can get a pretty good answer, a good enough answer for us to move forward. Here's the kinds of things that feed into the uncertainty: clouds and aerosols, aerosols from soot particles or other kinds of particles in the atmosphere. Really trying to put these very small scale processes into these big models. It's not easy, but we're slowly getting there. But what you find is that there's a range of answers here. I call this a fat tail. It's the probability distribution for how warm the atmosphere would get if you added a certain amount of CO2. So I apologize if we're getting a little bit too technical, but the idea is if we add a certain amount of CO2, we expect a certain temperature. But the fact is the models will say there's a certain probability of getting even higher temperatures. In other words, it's not uniformly distributed, equally high and equally low, but there's a higher percentage of getting a worse impact, a higher temperature. And this is something that's of great interest to the insurance companies, because as they try to write policies for how they think things are going to happen, they have to worry about greater risk in the future. So this is a topic we could have a whole session on, insurance and risk and fat tails, but I thought I would just mention it because it's an interesting part of this whole discussion. So what do we expect to have happen in the future? Well, based on the way we're going now, we would probably end up in 2100 by a temperature increase in the world of about 8 degrees. And you can imagine the kinds of extremes that you would see with that. In order to keep the temperature down, we're going to have cuts in emissions. And that's really the hard part. Here's this sort of sense of what the world would look like in 2040 if we did not reduce our emissions. We have all these things that we've just talked about: heat and wildfires, heat stress and water stress, hurricanes getting stronger, floods and sea level rise. And the important thing is that this is not happening just in the US, this is happening around the world. And what happens around the world is important for us, particularly for our national security, but also for our responsibility as a wealthy country to try to help the rest of the world. There was a recent report just written in March by the National Security Commission pointing out that food and water insecurity were leading to increased migration, and this is something that the US has got to deal with. They understand the importance of the new health challenges and, very importantly, biodiversity losses. One thing is important about biodiversity: if a species goes extinct, it doesn't come back if you cut emissions. It's gone forever. And so biodiversity losses are a key element of what the world is going to look like as we try to deal with climate change issues. Well, nations have been concerned about this, and the first big meeting to take it on was in 1972, meeting in Stockholm on changes in global change in the environment. And the most recent one that had a big impact was the Paris Agreement in December 2015. Actually, Emily and I were at that meeting and had a chance to see that negotiation taking place. The idea was recognizing that the temperature would be at least 5 degrees if we didn't do something. And I just showed you that if we kept on the old trajectory, it would be more like 8 degrees. To try to limit the temperature to 4 degrees and to pursue efforts to try to get it down just to 3 degrees increase from the pre-industrial average. Now, 3 degrees may not seem like much, but that additional change that we would see is enough to inundate many of the island nations around the world. And so you had the island nations pushing hard in Paris to get this agreement about keeping temperature down to 3 degrees. That's about 1.5 degrees Celsius, which is where you see the scientific discussions focused there. But this was the idea of the Paris Agreement, and each country agreed that they would identify what they can do, and then they would propose that to the global conference on climate change, and then try to work to those numbers. What's difficult about getting there, how do you get from here to there? The current path we're on, and that we have been on for ever since the beginning of the Industrial Revolution, is to increase emissions. Every year we increase emissions. And in order to keep the temperature down, we have to decrease emissions. This is a big issue with climate change. You can't just stay on the same path. In order to keep the temperature down to 4 degrees, you've got to cut emissions by 3 degrees, 3% per year, 3% per year. Not increase the way you've been doing it, but decrease by almost 3% per year. And if you want to keep it down to 3 degrees, then you've got to cut almost 8% per year. Whereas most countries, certainly the developing countries and certainly the developed countries, are increasing their emissions. So you can see why there has been an issue. Can we really do this? You know, what's the gap between what we are doing and what we need to do? Well, in order to deal with that gap, you've got to look at where the energy is being used and where you could make a difference. Right now, about 66% of the greenhouse gas emissions come from energy use in the world. About 13% from agriculture, about 17% from cutting down trees and releasing that carbon into the atmosphere, and a little bit from waste and wastewater, mostly methane. But it's these areas where you've got to make a difference. You've got to change your energy supply. You've got to do something about transportation. You've got to have a better way of heating buildings. You got to have a better way of getting energy for industry to build things. And then we've got to deal with the gases that come out of agriculture, and we've got to deal with the gases that come out of the deforestation. So all of these things have to happen. I like to divide this up into 3, maybe four categories. And in a way, this is we're reaching the end of the first talk, and now giving you a little preview of what talk number 2 would be like. We're going to have a new energy transition where we do 3 things. We embrace carbon-free energy. This means solar and wind and all of those things associated with it. We need to capture the carbon that's leaking out of carbon dioxide that's leaking out of old wells and natural gas pipes. We need to put a price on carbon. The economists always say, if you want something to be scarce, you need to put a price on it. And so right now, the question is, how do you decide the price? What should the price be, and who should do it? But there are 40 countries around the world that are doing this now. So this is another really interesting topic that we'll take up in the next session. But then it's very important for us all to recognize that we're not going to be able to do all of these things. Energy transitions in the past have always taken several generations. When we transitioned from wood to coal, when we transitioned from coal to oil and then to natural gas, it was always a several generation, a 30, 40, 50-year transition to really get all the infrastructure in place to really make a difference. Well, we can't wait that long for climate change. We can't wait for the infrastructure to get in place. And fortunately, the Biden administration has recognized that, and I think is trying to catch up with the rest of the world on helping move this energy transition as fast as we can. At the same time, learning to adapt and to protect ourselves against the impacts of this warmer and wetter world that we're heading to. So you can see we have a lot of exciting topics to talk about in session number 2. But with that, I'll finish our session number 1, and I'd be very happy to take questions.
Hello, everybody. I'm Maureen Crowley. I'm going to moderate questions. There aren't very many in the chat room. I won't, but maybe you'll add some. I want to first thank Jim very much for his talk. Every time I listen to him or have a conversation with him, I learned so much. And it's really not, you know, I don't have a science background. So I guess I have a question to start off, which is, why are there so many people without science backgrounds, especially in our country, it seems, who aren't listening to the scientists, to the experts about this problem, and don't feel the sense of urgency that the science tells us we should have?
Well, you know, Maureen, that's a really good question. It is true. The United States has, according to the various social research that's been done, we have more people who are negative and deniers than any other country. I have to say that we're followed fairly closely by Russia and by Australia, that have not as many as we do, but still quite a few. And these the U.S., Russia, Australia, we're all very heavy fossil fuel users, and so one of the issues has been the disinformation campaign that the fossil fuel industry has used to say that this issue of climate change, yes, it's probably true. There maybe something could happen, but it's not that big a problem, and we shouldn't have to worry about it. In fact, ExxonMobil scientists published a paper in 1970 saying that this would be a serious problem, and actually predicting very closely what would happen. But ExxonMobil deliberately squashed that so that it couldn't be seen. But we've had various enablers ever since who for one reason or another have felt that they could gain something by trying to push this issue under the rug. And it's also true, it's to be fair, it's also true that the scientists themselves did not really come to a consensus on the importance of this issue until more like the 1990s. So it does take a while. You know, on the other end of the spectrum is China, where the polls, to the extent you could believe polls from China, say that something like 95% of the people believe that humans are responsible for global climate change. So, you know, that's true. But I think the good news on that issue is that there are fewer and fewer climate deniers. As we see more and more evidence, as the evidence is completely consistent with the science that we have, people are just kind of backing away, and they're talking about ways that we can adapt, and you see various think tanks just moving away from those denial issues and trying to focus on what are the exciting new things you can do with solar panels or wind power. So we're in the midst of a transition, and it is something that has been a concern, but I think we're moving in the right direction.
Thanks, Jim. We do have several questions now. First of all, one of our board members says these images and graphics are amazing, incredibly helpful for understanding the progression. And she also had the same question that I asked you at one point. One of your graphics indicated 55% heavy rainfalls in the Northeast. I'm curious about that. Why here? And is the region experiencing this directly addressing this reality?
Yeah, you know, that's a really deep question. Why does it rain in a particular place, and why does it rain more? I can only tell you that the rainfall in a particular location is determined by the geography and by the winds that interact with the geography. So it's the shape of the topography, you know, the mountains and the hills. It's what's on those mountains and hills, whether it's dirt or grass or crops or rock or whatever. And these things determine the kind of convection, you know, when the earth gets heated up and the air rises, convection and the winds. And it's the convection and the winds plus the amount of water vapor in the atmosphere that then can turn into rainfall. If there's a certain, what do you call it, dew point, it's just the right temperature for the rain to little raindrops to coalesce. So this is always, it's like it's the fundamental problem of weather forecasting. Is it going to rain on my little league baseball field next week? Or even 3 days from now. And that turns out to be the easiest question to ask and the hardest question to answer, because where and how it rains is always depends very much on local conditions. So it's a question of what you have in the Northeast and exactly how it would be. But you can see that just from that map, a big range across the United States. If you plotted that versus topography, and I haven't done that, but it would be interesting to do it, you would probably see a pretty good correlation.
Right. So the same board member has asked, and this was just occurring to me, Jim, if you could end your screen share, and Christina, if we could ask everyone to turn on their video, and people who want to ask questions can unmute themselves. They could actually, we're a small enough group that I think we could have a more fun discussion if we did that. So that's great. So Stephen, you had a great question that I've also asked Jim at various times. Do you want to ask it? Stephen is the president of the coalition. Stephen, do you want to go ahead and ask your question?
Sure, thank you very much. Yes, I was watching Fareed Zakaria on Sunday, and he expressed the opinion that wind and solar are obviously good options to pursue, but his opinion was the sun doesn't always shine and the wind doesn't always blow. And he was a proponent of nuclear energy being made safer, that there are so many ways that could be done, and that should be included as a solution to climate change. Your opinion about that, Mr. Baker?
Yeah, in fact, we'll take up this topic in a little more detail in session number 2. But it is it is a fundamental problem. I guess the question is, there are many wind and solar grids that have been put together, somewhat smaller ones, where you use wind and solar and batteries. And in fact, Elon Musk built a huge battery for a certain region in Australia, and has given a whole city a grid with a battery and with solar. And that seems to be working pretty well. That's been operating for about 10 years. So the question, sort of the specific question would be, is it faster to make really big, safe batteries than to make big, safe nuclear? We don't know the answer. We have a lot of bad experience with nuclear, and a lot of hopes that never came true. Okay, let's say that there are technical issues that need to be solved there, and not to mention the proliferation issue and the waste that we don't know how to solve those problems. But that's not to say that you couldn't do a better job with nuclear. But in my view, and you hear this a fair amount, why don't we put a lot of work into making really good batteries, because that's what you need, energy storage. And in fact, I heard Stephen Chu in his speech a few weeks ago talk about grids with energy, with the solar and wind, and how you could do storage simply by, when you have the energy, you pump water up to a high level, and then when you need it, you just let the water come down, and then it runs a little windmill, and then you get that. That's like the world's simplest storage unit for energy. But there's a lot of opportunity to use existing technology to make grids that can really work. The important thing is, and we'll talk about this in number 2, you want a smart grid, so that you've got a controller that says, okay, I just lost my wind, I got to get some battery there, or I have to get a little of something, something here or there. And there's a lot of lessons learned from the recent failure of the Texas grid, when the water and the natural gas froze, so they had issues there. But anyway, this is a really fascinating topic, and we'll take it up in more detail. But I'm glad you raised it, because that intermittent question is an important one.
Thank you.
So, Roger, do you want to unmute yourself and ask your question? It's a great one. Roger? Maybe I'll ask it for him. He says, what is the easiest path to take to reduce a major source of climate change where we have the best chance of success? Or must we address every source?
No, I think it's important to focus. There's really two things that you can do right now. If we just stop using coal, this is an important thing that we should stop building new coal plants. We should stop using coal. Coal is like the worst fuel that one can use, because not only does it emit CO2 and other gases, but it also puts a lot of polluting particles into the atmosphere. And we have lots of evidence about issues with health around coal plants and so on. The second thing that's really easy to do is to plug old wells and to fix the leaks. In fact, this is one of the topics I'll take up in number 2, but we have a lot of old leaky natural gas pipes around the country, and there are various environmental groups going around and mapping these. Just fixing those means that you're taking one of the very powerful greenhouse gases out of the atmosphere, which is really good. Or plugging old oil wells. You know, most old oil wells are not plugged. They just leave them, and so they emit whatever is down there. Sometimes it's a lot of methane, and spending the money to cap old oil wells, you know, that's a really good thing to do. So there is a series of things that one can focus on, and sometimes it's hard to see that when you listen to, let's say, the new administration proposals, which have a lot of things, and you think, can we ever do all of that? Well, you know, there is a way to have a set of priorities.
I really appreciate how you framed and had a conversation like this, very specifically with all the topics in a kind of very, you know, just a clear and kind of this is the scenario way, which is nice. I got a question. One of the things you didn't talk about was the you talked about the Holocene epoch. What's your thoughts on whether or not we've actually moved to the Anthropocene epoch, where we've changed the world enough to be considered a whole nother epoch? And
yeah, this is a really good question. You know, it's the question is really in two parts. One is, have we as humans affected the whole globe by doing our resource intensive lifestyle? And that's the first question. And the second question is, have the geologists recognized this to the extent that they're willing to give it a name? So there's, you know, like two things. So the geology groups have been meeting in their congresses, you know, trying to decide, should we give this a name or not, and what is the record? And of course, geologists like to give a record based on drilling and making a core in the earth, and then looking at the different layers. And when the layers change, they say, oh yeah, now we're in a new age. And so the question is, what layer are you going to see for this? And that's an interesting debate that's going on right now. And they deliberately make it a long process because they don't want to make it easy to make a change. But I think there is no question, number one, humans have affected the whole globe, because we have raised the carbon dioxide above the level that it was ever at for over 1 million years. And this is most important, we know that is carbon that was released from fossil fuels, because it's not just natural carbon, and it's not just trees recycling carbon, but it is ancient carbon, because it doesn't have any radioactive carbon in it. That radioactive carbon is all decayed away, and all of the natural carbon that we have at the surface of the earth is all radioactive. I mean, it's a tiny little bit of radioactive, a little bit of carbon-14, because it's constantly being bombarded with cosmic rays from the atmosphere. So we know that the plants and everything that we have on Earth today above ground has a little bit of radioactivity in it, a little bit of carbon-14. But the deep stuff, you know, the ancient plants and animals and so on that have been turned into coal and oil and natural gas, it's not there. So the isotopic signature is a way you'd say it scientifically, is proof that humans have affected the Earth. And so when I've been engaged in this discussion with geologists, I say, hey, just use the isotopic composition. The isotopic signature tells you that we're in the Anthropocene. I don't know how you say it, but
Yeah, I know it's like three
I
ways.
think we definitely, there is no question that we're there. And scientists started talking about this about 30 years ago. I remember they're saying, look, we're affecting the globe now. We're affecting the whole globe. This temperature, this CO2 increase, you can see it. You can see it everywhere. And it was those measurements that really made the difference. It's an interesting topic.
Yeah, will you be talking about geoengineering in the next?
Yeah, I definitely will. I have a lot of opinions about geoengineering.
Yeah, I'm sure.
So I will definitely talk about that. I think there are a lot of serious issues that have to be dealt with, and that some of the proponents don't understand the physics of what they're getting into. But it's a really, it's a fascinating question, because if you see a big problem, should you apply the solution that you know, or should you back off? What should you do? And it's these things are not necessarily easy decisions to make for society. Maybe a scientist can make a decision, but for society to make a decision can be complex. But definitely, we're going to talk about that in more detail. Yeah.
Perfect.
Jim, I want to, and everyone else, Sean is on our board, the embankment board, and he's also the director of sustainability at Diller Scofidio, who designed the High Line. So he's working in this area, and he'll be delivering a talk on our ecology vision for the embankment, hopefully in late May or maybe early June.
Okay, great. Yeah.
It's a vision that we hope to encourage other our parks organizations and trail organizations to adopt as well. So that will be coming up soon for people who don't already know about it. Jake, do you want to unmute yourself, because you had a question about mass extinctions that I thought was interesting.
Yeah, I was just, I've been talking to a scientist at the New York State Museum who's an expert on megafauna and also New York State. But I was interested in whether you think there's something we can learn from mass extinctions from, the ancient past that are related to climate change. Or I'm not even sure if that's an area of expertise for you, but you did touch on it briefly.
Yeah, there's a lot that we can learn. And this has been I would say, one of the areas of important advance in climate science is to look into the past and to be able to get more information from ice cores and from samples and learning about the temperature, the gas composition, and the various biological material and the kinds of life material that you can find, and then trying to understand from all these somewhat difficult pieces, but trying to understand when you put it all together, what caused one mass extinction over another. Was it a CO2 increase that had a big temperature increase? Was it an asteroid from outer space? And they've got a lot of evidence for how different things have caused different mass extinctions. I don't know whether we're on the 5th or 6th or 7th or something like that. Maybe we're on the 5th at this point. But it's been very, very valuable to test the ideas that we have from our current knowledge and of the physics and chemistry and biology of what we know, to compare that with what we have in the past, and because we know there have been these cataclysmic events. So it's not a question about whether they happened. We know they happened, and we know that what the impact was, and then to try to do that. So we've learned a lot about the physics of, you go back 100 million years, and back to the back to the Permian in these very, very old ages when you had very high CO2 levels. There's a lot of useful things we can learn. Plus, what we've learned about about climate science has been very valuable. Just looking back, I started out at the beginning, I talked about Roman history, for example, just looking at the fall of Rome and knowing what we know today about climate science and what we know about medical science, and then applying those ideas to history. It's like a whole new field. So we've learned a lot, and it's also given us some sense. We have our little part of history right now that we live in, maybe 100 or 200 years, but to think about, what might happen in 500 years, the Gulf Stream or so is that kind of information about what has happened in the past has been very valuable.
Bethany, do you want to ask a question?
Yeah, and this may be sort of more of a bridge question to kind of the next session, but you mentioned at one point about, you were kind of showing, you had a graphic that was showing like 5 days difference in cherry blossoms blooming and, migration of animals, although not their food sources. And one thing that I always think about when like the kind of poster child for climate change is kind of polar bears. And then you sort of have this kind of, a lot of people who are not paying attention to the details of it, who say like, who cares? So the cherry 5 days, oh, that's not so much. Do you know what I mean? So the sense of not really getting how significant a difference that is, and sort of how to take that information and use it or deploy it, for advocacy in ways that help people understand who are like not into the details. That's my question.
Yeah, I think this is a really good point. And biodiversity is something that it's hard to understand the issues of climate change, but it's even harder to understand biodiversity and why it's so important to us. And this amazing biological life that we have, that small animals can reproduce millions of times over, and just this short distance we've gone in trying to learn about this. I mean, you just think about the distance between understanding the shape, that double spiral shape of DNA, to the point of understanding RNA messengers, and then being able to build a vaccine faster than anybody ever thought based on the RNA messengers. This whole thing is just kind of mind-boggling. But we depend enormously on biodiversity. We depend on it for farming, for food. We depend on it for protection, like the Amazon rainforest. So I think the more we can find ways to make those points, the better, because it is actually it's a critical aspect of our, we live this resource dependent life where we keep using more and more resources, and we're degrading the diversity of the world around us, and we really ought to be protecting that diversity.
Right. Yep. Thanks.
Yeah, I was telling Jim, I listened to a talk by the head of, I believe it's called the Earth Institute at Columbia University recently, who hopefully may speak directly to us. He indicated he was willing to do that. And he was saying, climate change is on everybody's lips now. Everybody who's at all informed knows it's a crisis, but biodiversity is not. And yet he says, biodiversity is the worst crisis, because once you've lost a species, you're not going to get it back. Whereas at least theoretically, you can ameliorate climate change or even reverse it, at least theoretically. So,
I know these are both serious issues that society has not come to grips with. In the end, as I said, we've got to find a way that we can't just continually destroy the resources of the earth, because it's a finite earth. And whether we can find a way to live that way with 12 billion people, which is what the World Bank is currently saying that we will level off our population, but we're using more and more resources. And can we get less resource intensive, and can we protect the biosphere? These things all go together, and it requires having a sustainable mindset, which is really the most important thing.
Right. Well, and also I feel like interdependence, right? The sense of interdependence that I feel like, ecologically, and I think, in communities that are, it just sort of happens at multiple levels, interdependence, right? So we're talking about biodiversity, and anyhow, it happens at all different levels, and there's a lot to think about there.
Yeah, and it's been hard. It's been hard for us in the U.S. to really focus on this, because we started as a country that was expanding out into what we said was an open, endless frontier. And of course, a lot of people still believe that, and we haven't really taken a sustainable attitude. We never really learned about how we can use energy in the right way, and dealing with the biosphere, I think, is a really important topic. And fortunately, I think there are people like this group and others that are starting to think about that. And the more we get those ideas out and get them into the into the heads of the elected officials, the better off we'll be.
Cynthia, do you want to ask your question?
Sure. When you showed that graphic on how many cows there are today, and there was much more diversity of larger animals in the past, and I'm not a cow expert, but I do believe that part of the problem is they burp more because they have so many stomachs, and I don't know about sheep and goat burps, but is there any progress in reducing the dependence on cows? Because it seems that we have an awful lot of dependence on cows.
We do, and there's a huge beef market. The U.S. is one of the big players, and of course, we're responsible as a country for part of the Amazon deforestation, because it is very effective for Brazil to cut down the Amazon and to have cattle ranches and to sell the beef to America. It's not the only country, but we're a huge player there, and so you lose the Amazon, and you get more cattle, which, as you saw, emitting more methane. Trying to get away from that, I think, is important. And there's a lot of interesting stuff going on now with beef substitutes, Impossible burgers, and things like that. But trying to turn that industry around, I think, is it's not going to be easy. With between beef and soybeans, which is the other thing that happens when Texas had the big ice storm, they lost a lot of their soybean crop. And so what happened was Brazil cut down a lot of the Amazon to create new soy farms to export soybeans to the U.S. So these things are all connected, and you wish we could get a little more linked up. But maybe I think the Biden administration, these people understand these things. John Kerry certainly is very, very knowledgeable about this. And I think the more you can expose these things and people understand what's happening, they can say, hey, wait a minute, I didn't sign up for that,
So Joanne, you had a question that may be appropriate for the second talk, but I think you should ask it just in case you can't make our second talk, because it's very much on, I think, everyone's minds. What can we little people do in our own lives to help ameliorate this problem? So,
sure,
Joanne?
there's all sorts of things, but they're very large. What does an average person do? Change their light bulbs, recycle, blah, blah, blah. What is the impact of an electric car? At some point, the car I have to make a choice. So it's a quiet, it's just one of the questions on what does the average person do? What's the checklist for the average person? Where is this guidance for the average person to, like, what's the biggest thing they should be focusing on? don't have hamburgers, don't do this, don't do that. But like you said, it's also connected. You don't drive, so maybe you get a delivery from, we had a pandemic, a lot of things were delivered to us. That's more or less driving. All these delivery services now is how people get their things.
Yeah, this is a really good question. So it's a deep and fundamental question about how society operates, any individual is not going to make a huge difference unless you are that individual like Bill Gates or Elon Musk, who gets lucky and happens to be in an industry that gets magnified because there's millions of people and it's the right time, whatever. So you have a few rich people who can do things. For the average person, you change your carbon habits, you're not going to change the world carbon budget that much. You change a little bit, but not much. But where you can have a huge impact is writing to your elected officials. Elected officials don't hear that much from their constituents. It's really quite amazing. And I worked in the government for really at a high level for 8 years, and I had a really good sense. I knew a lot of members of Congress, and we talked about how you could get people to understand that it's important not to pollute a beach, but to keep it clean, because you need a clean beach, but you also get tourists, so that's good for the economy. These kinds of things. But most of these people would tell me, okay, Jim, I agree with you. Yeah, what you're saying is right, but how come I don't hear from anybody about this? Why don't my constituents tell me that this is important to them? And I think people talk among themselves, they talk among their own groups, so I'm not saying everybody that nobody does this. I mean, there are groups that do it, but writing and expressing yourself to elected officials, or running for office yourself and being involved in some level, whether it's a town or city or state or it doesn't have to be national office. This is really important because it's getting this coalition together and having elected officials think, oh yeah, people care about that. That's something we have to worry about. Then when a bill is put forward, they can think about it. And the effective people who can really make a difference have learned to do this. I mean, a good example are commercial fishermen who work on a ecological resource, and they, to a person, they are always pushing for higher quotas for fish. Now, that's not a good thing to do, because you really want to push for the sustainable quota, not the highest quota, but the sustainable quota. But it's a huge lobbying power. And I've always wondered if there could be other groups. I mean, I know there are groups that do this, but you talk about an individual citizen writing to your member of Congress and being vocal about what you do, writing an op-ed for your local newspaper. These things help change opinion, and we have a big change that we need to make in a country like ours. Even though you have something like 72% of Americans in the polls say, yeah, we're concerned about climate change, we think we ought to do something about it. We're not yet to the point where people are willing to say, I'm willing to pay another $1 for a tank of gas in order to deal with the carbon dioxide problem. And so, how do we get there? You've got one good step. You've got an administration that would really like to do something, but they need support from the citizens. And I think, this is the last part of the sermon here. I think that trying to live a sustainable life is a way to kind of convince yourself that this really makes sense. So, owning an electric car is better than not having an electric car. Using green energy to heat your house is better than not doing that. Donating to projects that plant trees or capture methane. This is something. And now, just to give you a little preview, in the second talk, I finish up with a point, and I can make the same point here. One thing I thought, can I really make a talk like this and then make all these big pitches for the fact that you've got to save energy and be sustainable and so on, unless I do it myself? And what can I do? Well, I looked at what an average household emits and uses in terms of carbon dioxide per year. And then I figured it took me like 2 months working. I'm doing like 5 different talks on climate to different groups over a period of a few weeks here. I figured that's about 2 months of work. So 2 out of 12 is like 1/6 of a year. And a typical household emits like 30,000 pounds of CO2. So 6 into 30 is like 5,000 pounds. It's like a couple of tons of carbon dioxide. You can look at the numbers. And so then I looked around to see companies that did projects that would plant trees or capture methane, or what would they do, and how much would it cost to do that. It turns out it costs you about $40 per ton. So we call back a couple of tons, it's like $80. So I figured $80 plants enough trees to consume the carbon dioxide that I emitted while I was making this talk. Okay, so the talk was carbon neutral. So that's one thing you can do. But it's trying to think that way, I think is important. But I have a whole set of slides about what individuals can do, what cities can do, what towns can do, what states can do, and we'll finish up our session next time with a whole focus on exactly that question. And so hopefully you'll get some good ideas from that. And I've got a reference list of books and websites that can tell you. But I do think that individuals can make a difference. I really do.
Thank you.
So, we plan to end this program at 8:18. I think Jim's willing to go on if people have more questions, and I'm certainly always interested in listening more. A friend, Roger Heitman, he must be having signaling problems because he's been leaving and coming back in, but he had a great question. Roger, are you able to unmute yourself and ask your question about China? Or should I ask it for you? Well, if I don't, it looks like you've unmuted yourself. Why don't you go? Why don't you ask?
Yeah, I was just wondering, with the president's speech the other night, he was talking about competition with China and how we need to compete with China. And I was just wondering how we can compete with China, and because it seems like competition often leads to climate change. And how can we still compete but not also affect climate change?
Yeah, this is a really good question, and China is obviously a big player today. If you look at all the emissions that have been emitted to date, the U.S. is the biggest emitter. But if you look at what is happening today in terms of emissions per day or per year, China is the biggest emitter, and shortly India will be right behind them. So China is a huge player, and China has been trying to do 2 things at once. China is trying to grow rapidly to get a high standard of living for everybody in the country. So they have all of the signs of rapid economic growth, and rapid economic growth is synonymous with using more energy, and they have used energy in a way that has been the cheapest way for them to do that, which is mostly coal plants, but also lots and lots of solar, lots and lots of wind, and they have planted more trees than any country in the world in the last 20 years. So you have a country that it's like doing everything. They're trying to raise their standard of living using a lot of energy. They have a lot of coal, and they're using that coal. It's a little difficult because the coal is mostly in the far west, and it has to be transported to where most of the people are on the eastern coast. But they use a lot of coal, and they import a lot of coal. They import a lot of coal from Australia. Actually, the coal from Australia is even a better grade, so it's less polluting. But the pollution from coal plants has been a huge problem in China, and they when they had the recent Olympics, they just shut down all the coal plants around Beijing, so you couldn't see the pollution. But I had the same sense. Why are we competing with China? Why aren't we agreeing between the two of us that we are going to make the cleanest world possible, and try to see how we can get off coal as fast as possible and get onto renewable sources of energy. And if China has new ways, new technologies of making these renewable energies work better, then we should be trying to adopt that. In fact, they sell most of the solar panels in the world. They've been able to make that cheaper and cheaper, and if they can do that, that's something we should take advantage of. But I think it's difficult to think about moving from a world where there's one country dominant, and the U.S. is used to being the superpower, and recognizing that kind of designation is probably not so sensible anymore, especially with the size and power of China, and trying to find some way to cooperate so that we both don't go down flaming in a world that's so changed by climate change that you don't have the high standard of living that you're both trying to get to. So I would prefer to see this argument along this discussion along the lines of let's try to cooperate, make the world's cheapest solar panels, get them out there, make wind work, figure out how to make smart grids, and to do all those things that countries need. Look at Nigeria. Nigeria by 2040 will be the third most populous country in the world. All of those people are going to need a lot of energy to live a life that has a reasonable standard of living. You've got 5 million Nigerians now using solar power, but why couldn't we cooperate and make Nigeria a poster child? Well, there's a lot of reasons. It's very difficult to get in there with the long history that Nigeria has and the close connection with all the powerful oil companies that don't want to make a change. But you just recognize the issues. But yeah, I think this idea of a competition is not the way that we're going to become a sustainable world. But how do we get from here to there? Once again, I think John Kerry is a person who has the right blend of experience. At least, he's not a secretary like Rex Tillerson, who said climate change is just an engineering problem. Just solve the engineering and we're out of here. But recognizing the social impacts and the many foreign policy impacts and the effects on the developing world, this complex issue that I think John Kerry understands. And so hopefully we can get there and we don't get too engaged in military issues or conflict over Taiwan or whatever. These things can also happen. But this specter that we have of a world that has warmed so much that most developing countries can't have agriculture, and that we've melted all the ice caps and we have serious flooding around the world. This is something it's not good for China, and it's not good for us. And one of the things that happens with the rising sea level is the Chinese lose all the islands that they have in the 7-dash line area, and so they lose their claims for territory there. It's not something they're interested in either. Anyway, you can see that this topic ranges over a lot of subjects, and so I think we'll definitely take it up next time too, certainly to some extent. Good question.
Yeah.
This is on a very much lower level than that, but it has to do with commercial ideas and how popular they are, and how, you're talking right now to a group of people who are very engaged civically and always thinking about how we can help ameliorate problems or solve problems, that civic problems. And yet there's obviously, people with a lot of genius for looking at the polar ice cap melting and thinking, how can I make Greenland ice cap water and bottle it and sell it? Or the big shipping industries who see this, better path for commerce than the Suez Canal. It's appalling. I think it's appalling to people like us. And yet those interests seem to be so powerful. And so there's the whole psychology also of that, that's, how do we counter that?
It's true. You've got people with enormous power who can change the world and are not afraid to do it. I mean, I don't think it was and really an offhand remark by Trump when he said, why don't we just buy Greenland? I think he had been convinced by people, and obviously he's very interested in real estate, that this was a really good opportunity for lots of strategic reasons, and because of climate change would become very, very important. So to me, this was Trump's statement. I understand that climate change is really important, but there he's trying to do something, and the question is, how can you get people to do the right thing and lead us towards a more sustainable world? If you have these groups of multi-billionaires, shortly, certainly, in the next 5 to 10 years, we will have trillionaires. There's no question about that, because you've got people who have 200, 300, 400 billion dollars, trillionaires who with just a small decision can have a huge impact. And this is something that's never happened in the world. Well, I suppose Emily would explain in history that you've got rulers that can command huge armies and have a huge impact, and maybe there's some similarity there. I don't know, but anyway, this is something that we have to learn how this all comes together.
So does anyone have another question? If so, please unmute yourself and ask your question. And if not, I'd really like to thank you so much, Jim. I think, Bethany brought up a question in the chat that I don't think we really addressed, but it had to do with the language in which we talk about these things and what is the most effective language. I heard James Carville, who's always very humorous, talking about this the other day, about how certain people, that the Democratic Party has been taken over by academic language, and that doesn't work with normal people. And I just find that you're able to speak to people without a particular background in science or economics, which is really important, or all kinds of subjects in which a lot of research exists that we can't understand without having a translator like you. And I really appreciate it. And I think everyone, would agree with me that this talk has been great. And thank you very much. I really look forward to the next talk on May 13th at 7 p.m. On solutions, which I think all the people here are very, should I use the word desperate, to know what we can do.
Yeah.
Thank you so much.
Great. I enjoyed the questions. Lots of good thoughts, and we'll have a chance to talk more next time.
Thank you so much.
Thank you.
Bye.
Night.
Thank you. Good night.
Bye, people.